In this lesson we're going to continue to look at the uses of nuclear radiation. In this session we're going to briefly look at a few medical uses. Okay, so the first one is for sterilizing medical equipment, and that's going to require a gamma source, so we require gamma radiation, and a typical source for this is cobalt-60, which is a beta emitter, so that will decay into nickel, which is one step up in the periodic table, and we get a beta particle and the gamma radiation, which is what we require really for this sterilizing. Okay, so this method is also used for sterilizing packaged foods. The next important use is for medical tracers. So tracers are used to show up internal parts of the body that aren't functioning properly. For example, problems with the circulation or the nervous system or particular glands or organs that aren't working properly. So for this type of use you want a radioactive material which has got a short half-life. So you don't want radioactive substances hanging around in the body for long periods of time. And you also want either beta or gamma emitters, because alpha emitters are dangerous. They have a short penetration and they have high ionization power and so can cause cancers. What you want here is that the emitted particles quickly leave the body and are detected by a scanner which can form an image of the internal functioning of the body. So a typical tracer might be iodine-131, and there are many different radioactive isotopes that are used for tracers. Okay, so iodine, and that's used typically for imaging thyroid gland. The thyroid gland tends to accumulate iodine, so iodine is a very appropriate tracer for this particular function. And not only is it used for imaging the gland, it's also used to treat thyroid cancer. Now, just before we move on to other medical uses, we could remember that also medical tracers are used, for example, in identifying leakages in the circulation system. For example, after an accident there may be some internal bleeding, or for example blockages as well. So another typical source for this might be technetium, which is used as a pure gamma emitter. Okay, so it makes use of the unstable metastate of technetium-99m, and that decays into technetium-99 plus a gamma ray. Okay, so not only are radioactive isotopes used for tracers, but they're also used to help cure cancers. And there are two types of treatment. One is internal, where the radioactive isotope is injected near to or in the cancerous tumor. Now in this particular case you want a source that will do as much damage as possible, but you don't want that source hanging around for long periods of time. So this should be an alpha source with a short half-life. We want an alpha source because we want to kill as many cancer cells as possible, and we want a short half-life so that the radioactive isotope will soon disappear from the body. Okay, and the other type of treatment is external treatment, and this involves directing either gamma rays or high energy X-rays onto the affected area. So we want a source which is a gamma source for this purpose, and typically cobalt-60 will do this job.